Bismillahirrahmanirrahim. Assalamu alaikum warahmatullahi wabarakatuh. So in our today's video, we are going to discuss about the value of different trigonometric ratio for different angles. Okay, so mainly the angles that we have to learn the value of are 0 degree, 30 degree, 45 degree, 60 degree, and then finally 90 degree. Okay, for example, we have to know the value of sine 0 degree or sine 30 degree and so on, and same values for like cos also, cos 0, cos 30, tan 0, tan 30, cosec 0, cosec 30. So there is actually a table of that, as you can see this table. Okay, from this table we might have to use the value of, let us say, cos 30. I will show you. Wait. Yeah. So maybe in some problem I might be in need of using the value of sine 30. So this is the line of sine and this is 30. So the value of sine 30 is 1 by 2. So instead of 1 sine 30, we will replace it with 1 by 2. Then sine 90 is 1. Or for example, cosec 45. So this is the line of cosec and this is 45. So the value of cosec 45 is root 2. So today we are going to see how these values are coming, how the mathematicians got this value. Okay. Acha. So we will start with the value of 45 degree. Okay. First we are going to see how the values for 45 degree were invented. Now again, trigonometry deals with the right angle triangle, and we have a right angle triangle here. Let us name it. Let us give it a name ABC. And as we are talking about 45 degree, so let us say this is 45 degree. Now as per our discussion in the last video, you know that if one of the acute angle of a right angle triangle is known, then we can easily find out the other one, right? So if it is 45 degree, then this will also be 45 degree. And when these two angles are equal, their opposite sides are also equal, right? So the perpendicular and the base that we have here will be equal. So if I consider that AB is A, okay, so BC will also be A. So if I consider these two to be A and A, from this can I find out the length of the hypotenuse? We can easily do it according to what? There is a theorem, right? Pythagoras theorem. So according to Pythagoras theorem, we can write the hypotenuse square, that is AC square, should be equal to AB square plus BC square. So AC square equal to, AB will be replaced by A because AB, the length of AB is A, so A square, then BC square, BC is also A, so it will be also A square. So AC square is equal to 2A square. Now AC equal to, what can we write? If the square is transferred to the other side, it will become root over. So 2A square. Now this 2A square can be written root 2 into root A square, like root over can be written separately because both of them are in the root over. Now AC equal to, see, root 2, it will remain as it is, but here the square and the root over, they will cancel each other and it will become A. So we got the length of the hypotenuse as root 2A. Okay, now this is the hypotenuse and there is no doubt about it, right? This is our hypotenuse. And which one is opposite? If we are considering this angle to be our theta, okay, so this will be our opposite and this will be our adjacent, correct? Some may consider this one to be theta also. The result will be same, no problem. Then that time it will be opposite, this will be adjacent, but still the value that we are trying to find out, the values will be same, no worries. Okay, then let us try to find out the value of sine 45. Then let us start with sine 45, then gradually we will try to find out the value of cos 45 and then tan 45. If we get the value of these three, the other three is easy to find out because they are just the opposite of these three, correct? Okay, so sine 45, sine equal to what we know, opposite by hypo, right? Opposite divided by hypotenuse. So opposite for 45 degree, opposite is this one, which is a, and hypotenuse, it is this one, root 2 a. So a ones are a is cancelled, then we can write 1 by root 2. So that is the value of sine 45. Similarly, we can do the same for cos 45 also. It is adjacent divided by hypotenuse. So adjacent, which is also a, divided by hypotenuse is root 2a. So similar 1 by root 2 will be our value. What about tan 45? We have a little bit of lesser space here, so let me just write it in some other side. Let me write here, we have a space. So tan 45 degree, it should be equal to opposite by adjacent. So opposite is a, and a adjacent is also a, so a divided by a. So when we divide something with the same amount, then it becomes 1, right? So it is equal to 1. So the value of tan 45 is equal to 1. So sine 45 1 by root 2, cos 45 1 by root 2, and tan 45 is 1. The other three we can write from here itself. For example, sine 45, the opposite of sine 45 is cosec, right? Cosec 45. So if it is 1 by root 2, it should be root 2 divided by 1, right? The reciprocal. Now divided by 1, it doesn't actually bring any change. So that is why we can write it just root 2. Okay, anything divided by 1, it is the same amount only. So same goes for cos also. Okay, the opposite of cos, let me write it here, sec 45. So it will also be the same, 1 by root 2 will become root 2 divided by 1. So I can write it root 2. And then for cot 45, if it is a by a, so if I make it reciprocal, still it will be a by a, and the answer will still be 1, right? So now we can go back to the table that we have and check whether our answer is correct or not. Okay, let me just erase the previous marks. Okay, so the value that we saw were of sine 45. You see, sine 45 1 by root 2, cos 45 1 by root 2, and tan is 1. And cosec, it is just the opposite of sine. So 1 by root 2 will become root 2 by 1, and it is root 2. Sec also root 2, and cot is 1. So we got the same values, right? So that is how the values were invented. So in the same process, the other values can also be found out, but I'm going to show you one more, only 30 degree. Okay, so 45 and 30 degree, these two I'm going to show how the values are found out in this video. For the others, you can try to find out at home. Okay, okay, so for 30 degree, now we want to investigate the values of trigonometric ratio for 30 degree. Okay, now for 30 degree, we need a equilateral triangle. Okay, so you can see that we have an equilateral triangle here. Let us name it a, b, c. Okay, now for equilateral triangle, we know that all of the angles are 60 degree. Okay, so this angle is 60 degree, this angle is also 60 degree, and this angle is also 60. All three of them are 60 degree. Okay, all three sides are equal in an equilateral triangle. All the three angles are also equal. Okay, now but I need 30 degree, correct or not? So to get the 30 degree, how what can we do? This angle, that is 60 degree, can be divided into two equal part, right? See, the total angle is 60 degree. Now 60, if I divide it into two equal part, how much should I get? 30 degree. That means the each part here, this part will be now 30 degree angle, and this part will also be 30 degree. Okay, and as we have drawn a perpendicular here, in equilateral triangle, this is a special characteristic that if you draw the bisector of an angle, that will be perpendicular on the opposite side, and it will also bisect the opposite side. For example, if I consider that the length of each side, mm, the length of this side I have considered to be A, right? So the all the sides will be A. This will also be A, and this whole side will also be A. Now, what will be the length of this part? What do you think? Try to make a comment about it, okay? If I name this point as D, so what should be the length of BD? What do you think? Interestingly, it will be half of BC. Okay, so the full side BC, it will be equal to A, because it is an, I will try to remind you that it is an equilateral triangle. So all the sides will be equal. If this side I have considered A, this whole side will be A. Now the half of it should be A by 2. Correct? So BD should be A by 2. Now from here, as this is a right angle triangle that we got ABD, from this right angle triangle, can I find out the length of AD? I can easily do that, right? How? Using Pythagoras theorem. Always it should come to your mind, okay? So according to Pythagoras theorem, I'm not writing that line again. According to Pythagoras theorem, I'm writing in short, but while taking note in your notebook, kindly write the full thing as I have written in the previous slide. If you want, I can show you. Here you can see that according to Pythagoras theorem, this line you have to write. Sorry. Okay. Now, according to Pythagoras theorem, what we can write, this is 90 degrees, so the 90-degree opposite side, it will be hypotenuse, that is AB. So AB square should be equal to the summation of other two sides square. Other two sides are AD and BD. Remember, we are talking about the right angle triangle, not the full equilateral triangle this time. So AB square equal to AD square plus BD square. Now AB is A, right? AB, this whole thing is A. Then BD is A by 2. So AD length we don't know yet, we are trying to find out, but BD is A by 2. So as there is a square, we have to put a square here. So A square equal to AD square plus A square divided by 2 square is 4. Now if I change the side, then A square will be here, A square by 4, this is positive. If I bring it on the left hand side, then it will become negative. Okay. So now if you do the LCM, 4 into A square, it will be 4A square minus, we have A square here already. So AD square, then now 4A square minus A square, that means 3A square. Okay, we had 4A square, from that we subtracted 1, so 3 will be left, divided by 4 equal to AD. Now sorry, this is AD square. If I want to write AD equal to, then this root over will be, sorry, square will be transferred to this side and it will become a root over. So 3A square divided by 4. Now what can we do? As the root over is above all of the number, we can write this root over separately on each of them, right? Root 3, root A square, root 4. Now why we need to do that? Because some of them have a square above it, so they will be, getting out of the root over. Now 3, there is no square on it, so it will become, it will stay root 3 only. But this square and A, they will cancel each other and it will become only A. Now root 4, okay, if you write it in the calculator, you know that you will get 2, right? But if some people might have difficulty in understanding, for them I need to show that root 4, this 4 can be written as actually 2 square. So that time root over and a square They will cancel each other and it will become 2. So that is the length of AD. So let us write it here, root 3 by 2 into A. Okay, this A can be written here also, or if I want I can, if I don't want to write here, I can write here also. It's your wish, no problem. Okay, in both the case it means the same thing. So for now let it stay here. Okay, so we know the length of all the three sides, correct? Okay, let me circle it out for you. This one and this one, and the length of this side is this. Now don't forget to name them, like which one is hypotenuse, which one is for example opposite and adjacent, like that. Okay, so this is 90 degree, so the opposite side of 90 degree is hypotenuse, so this is hypotenuse, I wrote in short. And then remember we are trying to find out the values of angles for 30 degree, right? So we have one angle here 60 degree. Should we consider theta? Remember, be very careful, very careful, because we are considering 30 degree. We are trying to find out the values for 30 degree. So for that, this is the 30 degree that we need to consider as theta. Remember, okay, this is our theta. So according to that, the opposite side of this one should be opposite, right? So this is our opposite, and then the adjacent side of it, this one will be our adjacent. Let me make some space to write. So this is our adjacent. Okay, let me erase other unnecessary stuffs also. These things we don't need right now. Okay, I think, yeah, now we can proceed with our calculations. So at first we were about to find out the value of sine, right? So we will start with sine. Sine for which angle? 30 degree. So sine 30 is, it is equal to oppo by hypo, right? If you remember, so kahtoa, right? I will write it here for you. So kahtoa. So sine equal to oppo by hypo. So for 30 degree, which one is opposite? This one is opposite, that is a by 2. So a divided by 2, and the hypotenuse is this one, that is a. So if I simplify it, then how is it going to be? A by 2, it will be as it is. Now this division, if I make it into, then the bottom fraction will become reciprocal. Now in bottom there is no fraction, only a, right? But if we want, we can make it look like a fraction, like divided by 1. If something divided by 1, if you write, you didn't actually make any change, right? A can be written equal to a by 1, because divided by 1 it does not make any change. So if you want, we can write it. We will do it so that we can make it becomes easier for us to understand what it will become when it becomes reciprocal. So a by 1 will become 1 by a, correct? So this a and a, they will be cancelling each other, so 1 by 2, this is what will be left. So the value of sine 30 is 1 by 2. Okay, so that is our first answer. Hmm. Okay, so next we will write the other values. Let's use different one. So cos 30 now. Okay, cos 30 is equal to adjacent by hypo. I would like to recommend you that pause the video and try to find out the value of other trigonometric ratios by yourself for 30 degree. Okay, and then you can match the answer with the table or with this video also. Okay, here I'm trying to find out. So cos 30 is adjacent. Which one is adjacent? We have our adjacent here, root 3 by 2. Root 3a divided by 2, and then we have hypotenuse, that is a. Okay, so now cos 30 degree, will be equal to this root 3a by 2, that is the numerator, and then again we will write it a by 1 so that we can write into 1 by a, correct? Then we can cancel them, a and a, they will cancel each other, so root 3 by 2 will be remaining only. So cos 30 will be root 3 by 2, and then tan 30. Tan 30 is opposite by adjacent, so which one is opposite? Opposite is a by 2. Adjacent, which one is adjacent? Root 3 a by 2. So now if I continue the calculation, you know what to do, like a by 2 into root 3a, it will be in the denominator now, and 2 it will be, just make it reciprocal. So a and a, they will cancel each other, 2 and 2 they will cancel each other, so 1 will be left. If there is nothing at the numerator of all of them are getting cancelled, then remember that there is 1. So 1 divided by root 3. So that is the value of tan 30. Now if I want to find out the value of the other trigonometric ratio, we can easily do that. We just have to make the reciprocal of it. So let me box it out, whatever we found out the value till now. Yeah, this one. And for tan I did not write, so let me just write it here, that tan 30 is equal to, we got 1 by root 3. Okay, so as you can see, I don't have much space here to write the other three, but other three I believe you can do it, because it is just the opposite of sine. Cosec will be opposite of sine 30, that is 1 by 2, it will become 2 by 1. 2 by 1 means only 2. And then cos 30, it is opposite of sec 30, right? So sec 30 will be 2 by root 3. And then tan 30, from here we can find out cot 30, it will be root 3 by 1, that means only root 3. So that's how you can easily find out the value of other trigonometric ratio. In this video I want to give you a little bit of homework, like for 30 degree I found out the values, right? You trying to find out for 60 degree, and there is a good news, for 60 degree you don't have to do much work, because this diagram will help you. Okay, like this angle is 30 degree, then we know that this angle will be 60 degree. Okay, as this is an equilateral triangle, each angle was 60 degree. Other than that, also in a right angle triangle, if one acute angle is 30 degree, to find out the other one you can just subtract 30 from 90, so it will give you 60. Now if I tell you to find out what is sine 60 degree equal to, okay, so you have to just rewrite that for this 60 degree this will be now opposite. So this is opposite and this is now adjacent, so all the values are calculated. You just have to replace it according to, if considering this one as opposite and this one as adjacent, just replace the value and try to find out the answer. So it's easy for you, right? Okay, now then, after getting all the answers, you come to this table and try to match whether all the answer that you got are correct or not. Okay, so I believe you can do that. And the case, you can see that it is not defined. Not defined, it is the case, when we have to divide something by 0. Okay, let me give an idea. If you write 2 divided by 0 in the calculator, then it will show you math error. So the scientists say that it is undefined. Why it is undefined? Inshallah, I will show you someday. Okay, in the class, it is an interesting topic to be discussed. Why it becomes undefined or math error whenever we divide something by 0. Okay, so inshallah we will talk about it one day. For now, you can just memorize these values, because you have to use these values in the exams. The values are available in calculator also. From calculator you can find out the values, but there is a little bit of problem for this values. For example, this one, 1 by root 2, whenever there is a root over in the denominator, for those you might face some problem. This one, okay, so what is the problem? Like here also, this value in the calculator, they are showing, sorry, So in calculator, 1 by root 2, it will not show you 1 by root 2. If you write sine 45, they will show you root 2 by 2. Okay, so you cannot write root 2 by 2, you have to write 1 by root 2. Now why it shows this way, I will tell you. 1 by root 2, in the calculator the program is set in such a way that there should not be any root over in the denominator. That is why what they do, they multiply a root 2 in the denominator and the same thing in the numerator to balance it out, right? So now what happens, root 2 into 1 becomes root 2, and root 2 into root 2, it becomes root 2 square. So root over and square, they cancel each other, then it becomes 2, and in the numerator it is root 2. Okay, so in this way they are finding out the values. But remember, if you have a value in the calculator like this, you cannot write it in this way, rather you have to write 1 by root 2. Okay, so please be careful about that. All other values you can get from the calculator itself, no problem. Okay, so I hope that was pretty much the discussion on the value of trigonometric ratios for different angles. I hope you understood, and if there is any doubt, do not hesitate to let me know through the comment section. Okay, I'll be waiting for your response. Thank you very much. Assalamu alaikum warahmatullahi wabarakatuh.